afternoon, everyone. Today we are going to discuss the 8th week chapters of chemical process technology. In this week, sir has taught about the methanol production, the formaldehyde production, the Fischer-Tropsch production, and other Sasol process and HDMS process. So we are going to discuss related question according to the chapters, and we'll be starting in 5 minutes. Okay, so we are going to start now. I hope the screen is visible. So let's start. So the first question is what is produced when methanol reacts with syngas? What is produced when methanol reacts with syngas? You try to answer first, then I will give the actual answer. What is produced when methanol reacts with syngas? So the answer is alcohol actually. So I have marked it wrongly. I am correcting it. Just a minute. So the answer is alcohol. So just a minute. So this is the methanol. This is methanol. It reacts with syngas, that is combination of CO and H2 produces C2H5OH. C3H7OH, that is the all kinds of alcohols. Okay, so the answer was alcohols. Next question is explain the reaction of formaldehyde formation. Explain the reaction of formaldehyde formation from ethanol. From methanol. Explain the formation reaction of formaldehyde from methanol. So there are two type of formaldehyde formation reactions from methanol. We will see this later also in this session. So CH3OH, when dehydrogenation happens, that means minus H2, it produces HCHO. That is the formaldehyde. And again CH3OH reacts with the oxygen, that is the oxidation reaction, produces HCHO plus H2. So you have to check the You have to check the stoichiometric ratio, but the main product is formaldehyde plus water. But in two cases, formaldehyde produces. So this is the reaction of methanol reacts methanol when dehydrogenation. The first one is the dehydrogenation and the second one is the oxidation or partial oxidation. So it will be half O2. Partial oxidation, then this comes. Okay. Next question is the methanol reacts with hydrochloric acid to produce trichloromethane. Methanol reacts with hydrochloric acid to produce trichloromethane. So these are all the applications of methanol. Methanol is one of the most used base chemical in the industry worldwide. So methanol can be used for formaldehyde production. Methanol can be used for, you have just seen, for alcohol production, for uh, other polymethyl methacrylate production, which PMMA is the this PMMA can be used in more other cases also. So this is the base chemical or intermediate chemicals for many of the other chemicals which are very much valuable to our environment or in industry or in our daily life, you can say. Okay, so methylamine is also produced from methanol. Uh, then PET, polyethylene terephthalate, is also produced from ethanol. So there are, even after dehydrogenation of methanol, some basic alkanes are also produced. So methanol has a huge uh, its applications. So this is one of them. Ethanol reacts with hydrochloric acid to produce trichloromethane. Is it true or false? So let's see what is the answer. Methanol CH3OH reacts with HCl, that is hydrochloric acid, produces CH3Cl plus water. So this OH is reacted with this H plus and OH minus ion reacts with each other and produces water, and CH3 and Cl reacts, produces CH3Cl. Okay, so this is not the trichloromethane. This is methyl fluoride. Okay, this is the methyl fluoride. So I have asked that methane reacts with hydrochloric acid to produce trichloromethane. So this is not true. Trichloromethane formula is trichloromethane, that is CHCl3. Also it is called chloroform. So the chemicals used here are same in both of the cases, methyl chloride and chloroform, but you have to see this number. Okay, so this is 3 moles of chlorine is there here, 3 moles of CH3 is there. Okay, so both are different, so it is false. Next question is, what is produced when methanol reacts with carbon monoxide? What is produced when methanol reacts with carbon monoxide? So the answer is acetic acid and methyl formate. So there are, this is the multiple options question. Okay, so you have to correct the both, otherwise you will get partial marks. So when methanol reacts with CO only, it produces acetic acid, that is CH3COOH, and again it can produce also methyl formate, that is CHCOOCH3. Okay, so that is the methyl formate. Okay, so this is only when the methanol reacts with carbon monoxide. Okay, but we have just seen before that when it reacts with CO plus H2, it produces alcohol. So both are different equations. So here the right answer is acetic acid and methyl formate both. Next question is, explain the methanol dehydrogenation reaction. Explain the methanol dehydrogenation reaction. Explain the methanol dehydrogenation reaction. So methanol dehydrogenation reaction, that means so this equation or this question you can see that it is not dehydrogenation reaction, right? Because dehydrogenation reaction means when we are decreasing the H2. So dehydrogenation reaction I have already explained here, that is when dehydrogenation reaction means it will form the formaldehyde. It is means the minus H2. H2 will go out. But here I have asked about the evaporation reaction rather. That means evaporation, when evaporation happens, when water when water goes out from a chemical, that is called evaporation. Okay, so here I have asked about the evaporation reaction. So here it will be methanol, that is CH3OH minus H. So this is the evaporation, water is taken out and it produces CH3OCH3, that is dimethyl ether, DME. Okay, so this is the first step. Again, if we take out water, it will produce ethene. Okay, then propene. Okay, so this is ethene, right? So CH2, C double bond, CH2. This is propene, CH3, CH, CH2. This is propene, right? These are the primary chemicals or basic chemicals, ethene and propene, alkenes. So methanol evaporation reaction happens. First produces DME, dimethyl ether, and again it is evaporated. Water is evaporated from DME. It produces basic chemicals like basic alkenes, that is ethene and propene. Okay, so you have to remember the difference between dehydrogenation and the evaporation reaction. Next question. Methanol reacts with acetone and HCN to produce DMT. Is it true or false? DMT means the dimethyl terephthalate. Okay, so methanol reacts with acetone and HCN to produce DMT. Is it true or false? So what was the question? Methanol CH3OH reacts with acetone, that is CH3COCH3 plus HCN, hydrogen cyanide, produces PMMA. Its structure is this. Okay, so there is a CH3, there is a C, okay, then there is also a CH3, there is C, and there is CH2. So this is the structure of PMMA, that is polymethyl methacrylate. Okay, so this is the actual reaction. So here it is false because I have said it is DMT. How DMT is formed? We'll see in the next slide. So from ethanol, how DMT is formed? So methanol reacts with P-xylene. is paraxylene. This is p-xylene plus oxygen produces DMT, that is dimethyl terephthalate. Okay, so this is the actual reaction of DMT. So when methanol reacts with paraxylene, it produces DMT, but when it reacts with acetone and HCl, it produces PMMA. Okay, so you have to remember what are the reactants and what are the products for different cases, because these all the things are very confusing to remember. So you have to practice it repeatedly and remember this, because you can confuse them easily. Okay, be careful here. Next question, explain the methanol formation reaction. Now till now we have learned about the methanol application reactions. That means what chemicals can be formed from methanol, but we don't know how. Here we are questioning how methanol is formed. Okay, so explain the methanol formation reaction. So there are main reaction. Okay, in case of methanol formation, there is a main reaction. So methanol forms from syngas. Okay, syngas means CO plus H2. Here it is 2 moles of hydrogen produces CH3OH, that is a methanol. Okay, also in main reaction, carbon dioxide also reacts with hydrogen. Here it is 3 moles of hydrogen and can produce methanol plus water. Okay, so these two are exothermic equations. Okay, and side by side there is a coupling reaction occurs in the same reactor, that is CO plus H2O produces CO2 plus H2. That is the water gas shift reactions. You know, it is the water gas shift reaction. So due to water gas shift reaction, carbon monoxide produces carbon dioxide, and this carbon dioxide also reacts with hydrogen, produces methanol. So from carbon monoxide and carbon dioxide, from both the cases, methanol can be formed. Okay, so these are the equations. Next question is, what is the thermodynamic limit of methanol conversion? What is the thermodynamic limit of methanol conversion? So here, feed composition should be 15% of carbon monoxide, 8% of carbon dioxide, 74% of hydrogen, and 3% of methane. Okay, so when we use the syngas, that means when we use carbon monoxide plus H2, temperature should be lower and pressure should be higher for higher conversion. Okay, For optimum conversion, in case of CO and H2, temperature should be lesser and pressure should be higher. But if we use CO2 plus H2, in that case, temperature as well as pressure should be higher for higher conversion. Okay, so in the syngas case, when we use carbon monoxide, we need to keep the temperature lower and pressure high, and for CO2 cases we need to keep both temperature and pressure high. This is the thermodynamic limit of the methanol conversion. Next question is the for a feed composition, which one is true? So I have just explained in this previous slide that what is to be done. So first option is CO2 conversion increases with pressure. Right? So you have seen CO2 conversion increases with pressure is a correct answer. CO2 conversion so it increases is right, obviously decreases will be wrong here. And CO conversion decreases with pressure is also wrong, because you have seen that CO conversion is also increases with high pressure. And similarly, CO conversion increases with temperature. It is also wrong, because we have seen at the low temperature CO converts to methanol in a much better way. Right? So the right answer is CO2 conversion increases with pressure for this feed composition. Next question is, in methanol formation, original catalysts are activated at high temperature. In methanol formation, original catalysts are activated at high temperature. Is it true or false? So, uh, according to the conventional methanol production process, original catalysts are activated at high temperature. Okay, it is true. Next, what is the optimum temperature for methanol formation to avoid catalyst sintering? What is the optimum temperature for methanol formation to avoid catalyst sintering? What is the optimum temperature for methanol formation to avoid catalyst sintering? So what is the sintering process? I can write here the definition. You can also see in the Google also. So sintering is such a process where the catalyst particles coalesce with each other and form a solid mass of material, okay, which doesn't melt. Okay, if solid catalyst particles uh, form a lump kind of thing, so that will not further be used, right? So that will not give effective result in methanol formation case, right? So that is why we want to avoid the sintering of the catalyst to get the original efficiency, to keep the original efficiency of the whole process. So sintering is the process of forming a solid mass of material through heat and pressure without melting to the point of liquefaction. So to avoid this catalyst sintering, we need to maintain the certain temperature inside the reactor so that methanol formation can go smoothly, can proceed smoothly. So the optimum temperature is the 570 Kelvin. Okay. Next question is which chemical increases the sintering? Which chemical increases this sintering? Sintering leads to the deactivation of the catalyst uh, solids, obviously, because they will club with each other and form a lump mass of particles which will not be effective for the reaction anymore. So which chemical increases sintering? The answer is steam or chlorine. Presence of steam or tiny amounts of chlorine increases the sintering inside the reactor. Next question is hydrogenation of carbon monoxide produces higher alcohol and hydrocarbons. Is it true or false? Hydrogenation of carbon monoxide produces higher alcohol and hydrocarbons. Hydrogenation of carbon monoxide produces higher alcohol or hydrocarbons. Is it true or false? So it is true. Okay, so hydrogenation of carbon monoxide produces higher alcohol and hydrocarbons during the methanol formation. Next question is what is the catalyst used in methanol production? What is the catalyst used in methanol production? So for methanol formation, copper-based catalysts are used. So the particular catalyst used here is Catalco 51(1). Okay, so it has three components. Okay, that is zinc oxide. Next one is alumina, and main component is the copper, which is the active catalyst component. Okay, so this type of catalyst increases the reaction in increases, so it increases the reaction activity, the reaction selectivity, and the stability of the catalyst rates throughout the year. Okay, so it doesn't go to sintering easily. Okay, next question is the how is syngas for methanol production formed? How is syngas, which is used as a raw material for methanol production, formed? How is syngas formed? So, steam cracking of naphtha. Wrong. Steam reforming of natural gas. Okay. Steam reforming of natural gas, that is CH4. So, steam reforming of natural gas means methane. First, the combustion reaction happens. It produces syngas, CO plus 2H2. Then again, the CH4 reacts with the steam, that is in the reformer section, that is called the steam reforming, and produces CO plus 3H2. So both are syngas, right? So steam reforming of natural gas is the right answer, not steam cracking of natural gas. Okay, you have to be very careful with these terms. Next question is the which chemical boosts the activity of catalyst in methanol production? Which chemical boosts the activity of catalyst in methanol production? It is the carbon dioxide. So 5% carbon dioxide can boost the activity of the catalyst in methanol formation reaction. Okay, so this is the answer, 5% of CO2. Next question, what will happen if methane is used as feedstock? What will happen if methane is used as feedstock? The answer is more of hydrogen will produced. If methane is used as the feedstock, more amount of hydrogen will produced. That means in the syngas, the hydrogen ratio will be much more than carbon monoxide if we use methane as a feedstock. Okay. Next question. Why is hydrogen or carbon monoxide ratio to be maintained at 2 mole per mole? So, for methanol production, this syngas, that means a H2 by CO ratio is maintained at approximately 2 mole per mole. Okay. So, if we don't maintain this, what will happen? If H2 by CO ratio is very much less than 2, byproduct generation will be higher. Byproduct generation will be higher. That means higher alcohols will be formed. Higher alcohol. So that means we want to uh, produce methanol here. But instead of methanol, or methanol will form in very less amount, methanol will form in very less amount. Rather, alcohol, then propanol will form in very much higher amount here. But that is not our desired product, right? We want to produce methanol here. So if we keep this ratio very less than 2, this will happen. And if H2 by CO ratio is greater than 2, it will produce excess hydrogen, right? Okay, that is produce excess hydrogen in syngas, which will be less efficient. Less efficient methanol will be produced. Okay, so these are the two disadvantages of not keeping the ratio at 2. Okay, so you have to be maintaining this ratio around 2 or near to 2 so that our desired product methanol can be formed. Okay. Next question is the why is 2 column used for refining methanol? Why are 2 columns used for refining methanol? Why 2 columns are used for refining methanol in the ICI process? So you have seen the ICI low pressure methanol process, right? So there you have seen that after the reactor, in the reactor the methanol is produced, then in the separator the gas and liquid portion is separated, and this liquid portion goes into light end column and then the pure methanol column. Okay, so why these are two used? So in these two columns, crude methanol is refined. Okay, crude methanol is refined. So in the first column eliminates the light compounds, light gases, contaminants, etc. Okay, so whatever the product of the bottom product of the first column, that goes into the second column, and second column separates methanol from heavy alcohols, that is the ethanol, propanol or butanol. Okay, so because methanol is our desired product, right? So that is why two columns are used to separate them. Methanol is captured from the top of the column, and from bottom steam, water, wastewater and high alcohols or heavy alcohols are collected. Next question, what type of reactor is used in Lurgi process for methanol production? What type of reactor is used in Lurgi process for methanol production? So the answer is cooled tubular reactor. Okay, cooled tubular multi-tubular reactor is used in the Lurgi process of methanol production. Rest of the Lurgi process is totally similar with the ICI process of methanol production. Only the difference is the reactor. Okay. Next, in the Lurgi process isothermal reactor, heat of reaction is used for what? In the Lurgi process isothermal reactor, heat of reaction is used for what? So you have seen in the Lurgi process they are using multiple tubes are used. So from top gas is going in, and from bottom gas outlet is happening, and there is a circular boiler feed water. This boiler filled water is sent from one side, and this actually cools the tubes where the catalyst particles are placed, and the reaction happens inside that reactors, and that is why we are giving boiler feed waters to maintain the temperature, because methanol production you have seen that it is an exothermic reaction, so temperature increases uh, with time. So that is why to maintain the temperature, this type of reactors are used in Lurgi processes. So it produces kind of isothermal reactor, and that heat of reaction is used for the high pressure steam. So heat of reaction in this isothermal reactor is converted instantly into high pressure steam. Okay. Next question. How much high pressure steam is generated and why? So the answer is this heat of reaction. You have seen that this heat of reaction is converted instantly to high pressure steam. This pressure value is almost about 40 bar high pressure steam is generated, and this steam is used in the distillation column to power compressors. Okay, so you have seen in the chart also, methanol production chart also, you can see that there are steam needs to be supplied in distillation column in both the distillation columns or for the compressor. So this high pressure steam is sent there. Okay, so this heat of reaction is not wasted. They are converting to high pressure steam and this high pressure steam is used in distillation column. Next question. Difference between ICI process, Lurgi process and Haldor-Topsoe process for methanol productions. So the difference is the reactors. So ICI process and the Lurgi process are exactly same. Only difference is the reactor. So in ICI process, normal reactors are used, and in Lurgi process, multi-tubular reactors are used. Okay, and third process is the Haldor-Topsoe process. In Haldor-Topsoe process, multiple adiabatic reactors are used. Multiple adiabatic reactors are used. Okay, so the difference is in the reactor only. But in case of ICI Lurgi process, one reactors are used, and in case of Haldor-Topsoe process, multiple reactors are used. In ICI, normal fixed bed reactor used. In Lurgi process, multi-tubular cooler reactors are used, and in Haldor-Topsoe, multiple adiabatic reactors are used. Okay. Next question: Syn gas flows radially in Haldor-Topsoe reactors. Is it true or false? Syn gas flows radially in Haldor-Topsoe reactors. So Haldor-Topsoe reactor means the adiabatic reactors, right? It means the adiabatic reactors. So in adiabatic reactors, the syngas flow is radial. But in ICI or Lurgi process reactor, the syngas flow is axial. Axial syngas flow in ICI and Jurgi process. Okay, but here it is radially flow, so that is why it is true. Next question: what is the alternative method of producing methanol? So till now also we have seen that the difference between the different methods of methanol production is the reactor only. So in the alternative method also the reactor is the difference. So here slurry reactor are used. Slurry reactor is used in which the catalysts are solid. That means the solid catalysts are suspended in an inert hydrocarbon liquid, and the syngas bubbles through the bed. Okay, so in the slurry reactor you will see that the solid catalysts, that the copper based catalysts are suspended in the liquid hydrocarbons, and whatever the syngas is produced, that is bubble through the bed. Okay, so that is the difference between alternative method and the other methods. Next question: high single pass conversion can be achieved in alternative method compared to conventional method. So in alternative method, high single pass conversion can be achieved of methanol than the conventional method. So that will decrease the expenses associated with the syngas compression, right? That is why it is true. Next question: what is the percentage of methanol consumption by formaldehyde production? So in the alternative method process is what? So in the direct conversion happens. So CH4 reacts with partial oxidation or oxygen, half mole of oxygen, and produces CH3OH directly. But we know that combustion zone, in combustion zone, CH4 is partially oxide, produces carbon monoxide and hydrogen, that is the syngas. And if it is fully oxidized, produces carbon dioxide and water, right? So if we want to do if we do these alternative experiments in a very controlled way, then instead of carbon dioxide, carbon monoxide, methanol will be formed, and that will decrease the greenhouse effect. That is the alternative process for methanol production, that is the direct conversion. Okay. but this ethanol yield is low, that is why it is a primary barrier for commercialization. Okay. Next question, what is the percentage of methanol consumption by formaldehyde production? So formaldehyde production is one of the main application of methanol. Okay, so that is 35% of methanol produced is used for formaldehyde production. Okay. Next question, what type of catalyst is used for formaldehyde production? What type of catalyst is used for formaldehyde production? So the answer is silver based. Copper based catalyst is used for methanol production. But now from methanol to formaldehyde production, silver based catalyst is used. Okay. Next question. What is the height of the silver catalyst bed inside the reactor, formaldehyde reactor? What is the height of silver catalyst bed? The answer is 10 to 50 millimeter. Silver catalyst bed has a height of 10 to 50 millimeter inside the reactor. Next question. In dehydrogenation method of formaldehyde production, distillation column is eliminated. In dehydrogenation method of formaldehyde production, distillation column is eliminated. Is it true or false? So you have seen that methanol can be methanol can form formaldehyde in two ways. One is a dehydrogenation reaction, or one is a partial oxidation reaction. So in dehydrogenation reaction, two distillation columns are required for refining the finally produced formaldehyde. But in case of partial oxidation reaction, only one column is used. Okay, because already in the first column only methanol conversion is almost 99%. So the answer is false here. It will be in partial oxidation method of formaldehyde production, distillation column is eliminated. Next question, how is ammonia gas converted to liquid? How is ammonia gas converted to liquid? The answer is at 7 atmospheric pressure and 25 degrees centigrade, ammonia gas is converted to liquid. Okay. Next question. Ammonia gas is transported at 1 atm and minus 7 degrees Celsius. Is it true or false? Ammonia gas is transported at 1 atmospheric pressure and minus 7 degrees Celsius. So, it is true. So, when liquid ammonia is transported from one place to another, if we want to keep it in this case we have seen if we want to keep the at 7 atm and 25 degrees centigrade, liquid gas, ammonia gas is converted to liquid. And if liquid ammonia is transported at 1 atmospheric pressure, then the temperature should be minus 7 degrees Celsius. So it is true. Next question, explain the reactions of Fischer-Tropsch synthesis. Explain the reaction of Fischer-Tropsch synthesis. So, the main reaction of Fischer-Tropsch synthesis. Okay, so alkanes can be formed from Fischer-Tropsch alkanes, alkenes. These are the main reactions. Okay, so alkane formation and alkene formation. So suppose so here NCO reacts with 2n plus 1 mole of H2 produces alkanes, that is CN H2n plus 2 and NH2. N is the stoichiometric number, stoichiometric ratio here. Okay, that means N defines actually how much carbon is present. Okay, depending on that, these other portions will be filled. Okay, if N is 2 here, so C2H6 will be formed. Okay. Next, the NC alkene. That is, its reaction is NCO plus 2N of H2 produces CnH2n plus NH2, right? Then in the Fischer-Tropsch reactions there are side reactions also. So the first side reaction is the water gas shift reactions. Water gas shift reaction. It is very common. You have studied it multiple times in this course, throughout the course. So it is CO plus H2O produces CO2 plus H2. Okay. So this CO, which is the feedstock for Fischer-Tropsch process, it reacts with water. This water is produced here and produces CO2 and H2. Okay. Next side reaction is the alcohol production. So this NCO reacts with 2N of H2, produces HCH2 whole N plus N minus 1 of H2. Okay. Another one is the Woodward reactions. That is the conversion of CO to CO2. That is 2 moles of C carbon monoxide produces carbon and carbon dioxide. Okay. So these are the reactions. The main reactions happens in Fischer-Tropsch synthesis is alkene formation. Another side reaction, water gas shift reaction is there. Alcohol production is there and carbon dioxide production is there. Carbon dioxide and carbon itself as a char production is there. Okay. Next question, what is the characteristic feature of Fischer-Tropsch process? What is the characteristic feature of Fischer-Tropsch process? So in the Fischer-Tropsch process, 1 mole of hydrocarbon molecule results in a heat release of 145 kilojoule. Okay, which is an order of magnitude larger than that of ordinary catalytic reaction in oil refining. Okay, so in oil refinery also these alkanes and alkenes are produced, but the alkenes produced through the Fischer-Tropsch process uh, pro produces more amount of heat releases more amount of heat, that is 145 kilojoule, which is an order of magnitude higher than the ordinary catalytic reactions happens in oil refineries. Okay, so high amount of heat release are happening here. That heat could be used for many other cases also, right? So that will be much more helpful. or autothermal, and that will lead to autothermal reaction also, right? That is why Fischer-Tropsch process is the advantage here in case of producing alkanes rather than in producing alkanes in oil refinery, right? This is the characteristic feature of this FT process. Next question, chain growth and chain termination are independent of chain length. Is it true or false? So the answer is true. Chain growth, hydrocarbon chain growth and chain termination are independent of the chain length. Next, with increasing temperature, what will happen to the chain growth? With increasing temperature, what will happen to the chain growth? So with increasing temperature, the chain growth value will be decreased. Okay? With increasing temperature, the chain growth value will be decreased. Next, which catalyst is not used in FT process? Which catalyst is not used in FT process? Which catalyst is not used in FT process? The answer is nickel. But nickel has a high activity, but it produces significant amount of methane. Okay, so methane production will be inappropriate for use in the transportation fuels. Okay, so that is why in the FT process, cobalt is used, rather nickel is not used. Next question, iron is more vulnerable to carbon compared to cobalt. Iron is more vulnerable to carbon compared to cobalt. Is it true or false? The answer is true. Compared to cobalt, iron is more vulnerable to carbon deposition. Okay, so that means carbon deposition will damage the iron catalyst used for the alkane production, hydrocarbon production in FT process. Next question, which catalyst is more vulnerable to sulfur in FT process? So there are two disadvantage of this catalyst, that they can that carbon deposition can happen and sulfur in the syngas can be present. So these two things can damage the catalyst present in the or utilized in the FT process, right? So you have seen that iron is more vulnerable to the carbon deposition, and here the cobalt is more vulnerable to sulfur. Okay, if a higher amount of sulfur is present as a contaminant in the syngas, it will damage the cobalt efficiency. Okay, here the right answer is cobalt. Next question: when iron catalysts are active in FT process? When iron catalysts are active in FT process. So at particular time range, but at particular temperature range, iron catalysts are active. So the temperature range is 300 to 350 degrees centigrade with H2 by CO ratio is 1.7 is to 1. Okay. At this, at this condition, at this ratio of the syngas and this temperature condition, iron catalysts become active in FT process. Next question: which one is H-rich syngas? Which one is hydrogen-rich syngas? So, hydrogen-rich syngas is natural gas. Okay. So, coal and biomass is carbon monoxide rich coal gas, syngas. Okay. Next is water gas if reaction produces CO rich syngas. Is it true or false? Water gas if reaction produces CO rich, that is a carbon monoxide rich syngas. The answer is true. Water gas if reaction means CO plus H2 produces CO2 plus H2, right? No, I said CO plus H2 produces CO plus H2. Sorry. Yeah. So that is the water gas shift reaction, and it produces CO rich syngas. Okay. That is why it is true. Next, which catalyst is more desired in CO rich syngas production in FT process? Which catalyst is more desired in CO rich syngas production in FT process? The answer is iron, because iron helps in water gas shift reaction, right? So water gas shift reaction means it will produce CO rich syngas, right? So this iron helps in more desired CO rich syngas production in FT process. Rather, cobalt is more desired in hydrogen rich syngas production. Okay, so that means hydrogen rich syngas is the natural gas. So when natural gas is used in the feed, cobalt catalyst is used. Okay. Next question. Cobalt catalysts are functioning at what degree Celsius? Catalysts can function at what degree Celsius in FT process? The answer is 200 to 40. So for iron catalyst, the functioning temperature is 300 to 350, but for cobalt it is 200 to 250. Next question. What catalyst is used to get paraffin wax out? What catalyst is used to get paraffin wax out? The answer is cobalt. So cobalt helps in to get the paraffin wax out of the natural gas, which is required for diesel fuel. Okay. Next question. How diesel output is raised? How diesel output is raised? So diesel output is raised to over 73%. Raised over 73% by a process called hydrocracking. By a process called hydrocracking. And this hydrocracking means it involves Heating the wax to a high temperature then saturating it with hydrogen. Breaking the large hydrocarbon chains into shorter chains. Okay, so hydrocracking helps in breaking the large hydrocarbon chain to shorter chain by heating the wax to a wax means a higher hydrocarbon chains to a high temperature and then saturating it with the hydrogen. Okay, so that is how diesel output is raised. Next question: ruthenium catalysts are operated at lower pressure, higher temperature, or lower temperature. Ruthenium catalysts are operated at lower pressure. Wrong. Higher pressure is right. Then higher temperature is also wrong, but lower temperature is right. So ruthenium catalysts in FT process are operated at lower temperature but high pressure, and it produces higher molecular weight hydrocarbons. Okay. Next, iron catalyst has higher activity in FT process. Is it true or false? So in FT process, iron and cobalt both catalysts are used, but cobalt has a higher activity and higher chain growth probability. That is why it is false. Here I have asked about iron catalyst has higher activity, so it will be false. Next question. In higher chain growth probability, LPG product percentage is more. So it is false because in the higher chain growth probability region, diesel and wax are formed. Okay. But in lower chain growth probability region, LPG fuel gas are formed. That is why it is false. Next, in FT process slurry reactor, mass diffusion is lessened by the small size of the catalyst particles. So in the slurry reactor, we have seen that solid catalyst particles are suspended in liquid hydrocarbons. So this solid particle size is very small. That is why mass diffusion is less in the slurry reactor if we use slurry reactor in the FT process. So the answer is true. Next question. Which reactor finds difficulty in separating product wax in FT process? The answer is fluidized bed. Because in FT process also slurry reactor, multitubular reactor and fluidized bed reactor is used. But in fluidized bed reactor reactor it is difficult to separate the wax from the suspended catalyst. Okay. So here the answer is fluidized bed. Next, how many types of reactors can be used in FT process? So the first type of reactor is multitubular cooler reactors where multiple tubes are used, right, for cooling. Second one is the slurry reactor. Okay, where catalyst, solid catalytic particles are suspended. Third one is the fluidized bed reactor. There are two types of fluidized bed reactor. One is the circulating fluidized bed, that is CFB, and the other one is the fixed fluidized bed, that is FFB. Okay, so these are three type of, or rather four types of reactors are used in FT process. Next, why is the selectivity of fixed bed and slurry reactors towards high towards the wax? Why is the selectivity of fixed bed and slurry reactors high towards wax? Wax means the heavy products, that is a higher hydrocarbon products. Okay. So the answer is low operating temperature. The selectivity of fixed bed and slurry phase reactors towards heavy products or wax is high because of their low operating temperature. The fluidized bed, the circulating fluidized bed operates at high temperature. Okay, that is why it is important. Next, what is the primary byproduct of fluidized bed reactor in FT process? What is the primary byproduct of fluidized bed reactor in FT process? The answer is gasoline. Gasoline is the primary byproduct of fluidized bed reactor which operates at high temperature and high pressure zone. Next question. Which reactor is the tallest used in FT process? Which reactor is the tallest used in FT process? The answer is the circulating fluidized bed. So circulating fluidized bed has a reactor height of 46 meter. Fluidized bed has fixed fluidized bed has 22-meter reactor height. Slurry phase reactor also has 22-meter reactor height, and multitubular has only 12-meter reactor height. Okay. Next question. What is C10 number? What is C10 number? So it is also denoted as C10 rating, and CN it is an indicator of the combustion speed of diesel fuel and compression needed for ignition. Okay. So what is the combustion speed of diesel fuel is can be indicated by C10 number. It plays a similar role for diesel as octane rating does for gasoline. Okay. The CN is an important factor in determining the quality of diesel fuel, but not the only one. Other measurements of diesel fuel's quality include energy content, density, lubricity, cold flow properties, and sulfur content. So CTN number is important for diesel, and for gasoline it is called the octane number. Okay. Next question. Low temperature FT reactor feedstocks are generated in low temperature Fischer-Tropsch reactor feedstocks are generated in 13 Lurgi gasifiers. Okay, 13 Lurgi gasifiers. Next question. What is the temperature of the reactor maintained in Sasol 1 process? So the input for Sasol 1 process is coal, oxygen, steam, and it reacts at certain temperature and produces syngas. Okay, and obviously ash. Main production is the syngas. So this Sasol 1 process is done at 1300 greater than 1300 Kelvin. Okay. Next question. When raw syngas is cooled, what can be extracted? When raw syngas is cooled, what can be extracted in Sasol 1 process? The answer is water and tar. When raw syngas is cooled in Sasol 1 process, water and tar can be extracted. Tar is used You have seen that the use of tar, multiple use of tar. Tar is used as road prime, as pitch, etc. Next, what are the products of oligomerization process in Sasol 1? What are the products of oligomerization process in Sasol 1? LPG and gasoline. LPG and gasoline are the products of oligomerization process. Next, what is the temperature of the vacuum column to create medium ox in Sasol 1 process? The answer is 590 to 770. Medium wax is medium wax is to create medium wax back in the vacuum column. 590 to 770 Kelvin temperature is maintained. To create higher wax, more than greater than 770 Kelvin needs to be maintained. Next question, what is the use of methane rich byproduct from cryogenic separation in Sasol 1 process? The answer is town gas. The methane rich byproduct from cryogenic separation is used to produce town gas, which has multiple applications. Further. Next question. What reactor is used in Sasol 2 and 3 process? The answer is FFB. That is the fixed fluidized bed are used in Sasol 2 and 3 process. Next question. Isomerization maximizes transportation fuel generation. Is it true or false? Isomerization maximizes transportation fuel generation. The answer is true. Okay. Isomerization maximizes transportation fuel generation. Next, what is the hydro dewaxing process? It is the process of removing long chain hydrocarbons through cracking and isomerization in the presence of hydrogen. So it is also another process of making long chain hydrocarbons through shorter chains, or removing the long chain hydrocarbons through cracking and isomerization on the presence of hydrogen. This process is called the hydrodeoxing process. Next, what catalytic processes are included in Sasol 2 and 3 process? So there are different catalytic processes are used in Sasol 2 and 3 process. Among them, the first one is the catalytic reforming. Second, excuse me. Second one is the alkylation. Third one is the hydrotreating. Fourth one is the oligomerization. The fifth one is the isomerization. Okay, so these are the catalytic processes involved in this Sasol 2 and 3 process. Next, what are the products of SMDS processes? What are the products of the SMDS processes? So SMDS means shell middle distillate synthesis. Okay, so their products are diesel, kerosene and naphtha. Okay, so these are the main products of the SMDS process. So that is from my side. I hope you will find this lecture useful. So So these today's lecture is important. So I just want to tell that this Sasol 1 process, what are the reactions involved here? You can go through this very carefully. Then the how pure syngas is formed here from the allergic using the allergic gasifier. Okay, we have seen this. There are byproducts also, but main syngas is also produced. Pure syngas is produced. You can check this form. You can check this flowchart. This is important. Then in the reactor section, okay. So in the pure after producing the pure syngas, in the reactor section, what other byproducts are formed? You can see heavy works, light works, gasoline, diesel, alcohols, ketones, LPG. Everything is produced along with the syngas, right? So this is also important. Then in the Sasol 2 and 3 process, we have seen the different catalytic processes involved, right? So first one is this catalytic cracking. Second one is the catalytic reforming, where isomerization, cyclization and aromatization happens. Then is the alkylation, where from single chain carbon produces higher branched alkanes. Then this is the hydrotreating, which produces phenols. Okay, production phenols, then phenol from phenols to benzene, then benzothiophene, thiophene, pyridine reactions are there. Last one is the hydrocracking. Okay, these are all important. And here also in the FT processor also, the comparison between the different reactors involved in Fischer-Tropsch process, that is multitubular reactor, the slurry reactor, then the fluidized bed reactor, that under it comes the circulating fluidized bed, its features, and the fixed fluidized beds and its feature. Okay, so everything is important here. You show the summary of the comparisons, and here there is a chart of, there is a comparison with the four reactors. The reactor height, diameter, tube diameter, number of tubes, catalyst size, capacity, potential, then comes inlet temperature, outlet temperature, pressure, H2CO feed ratio. Everything is compared between these four reactors used in the Fischer-Tropsch process. So you can obviously check it and remember it because they are important. Okay, that is from my side. I hope this you will find this helpful, and if you have any question, you can anytime message. Thank you for listening. Goodbye.